Today, we are going to fix the biggest problem with modern hi-fi speakers. See, if you want big, high-quality sound, well, then you need a lot of space. Take my desktop speakers here as an example. They aren't anything special, and yet they occupy like a quarter of the usable space here on my desk. And don't even get me started on my surround sound setup. So you can imagine how intrigued I was when I was watching YouTube the other day and I saw some creators building speakers with a technology that I've never even seen before. It's a little unconventional, but it promises to deliver insane sound quality in a form factor that's honestly a little hard to believe. So today we are going to build a set of those speakers, and I've even got some of my own little tweaks to add in along the way. Hey everybody, it's future editing Zach here, and I just wanted to add a note that at this point in the project, I was completely bought into the hype surrounding the style of speaker, but as the project progresses, you'll probably notice my tone starts to shift. These speakers ended up being far more complicated and nuanced than I ever expected, so at times, I was a little overly enthusiastic. All right, now that we got that note out of the way, let's get back to the video. So first things first, this is an exciter. And you can kind of think of one of these like the mechanical part inside of a normal speaker that moves the cone back and forth. Except this obviously has no cone attached to it. Instead, you attach it to a panel and the whole panel effectively becomes your cone. Now, this particular exciter has some cool features to it and we'll get into that later. But for now, I want to talk about the panel. You need something that's large, rigid, and lightweight. And the material that best fits that description, while still being cheap and easy to get, is XPS foam. Now, I did consider using some more exotic materials, but honestly, after listening to some sonic samples of this stuff, it sounds really good so long as you properly prep it. To kick things off, I started by cutting my larger sheets into some smaller, more manageable panels. But the sizing of those panels is anything but arbitrary. See, the larger the panel is, the better it can generate low frequency sounds. However, if you make it too big, then you run the risk of making it so heavy that the exciter will struggle to move it quickly enough to generate higher frequency sounds. So there's definitely a Goldilocks size that's relative to the strength of your exciter. And speaking of gold, you also don't want to make your panels square. After I cut them to width, I used the golden ratio to figure out their height. Cutting them into a rectangular shape like this discourages the formation of standing waves, which can degrade sound quality. In fact, avoiding symmetrical shapes in general will be a bit of a theme going forward. Next, we need to cut some corners. And to make sure I cut sonically optimal corners, I made this 3D printable jig. Just slide it over any ugly right angles and then use it as a guide to cut a much nicer sounding radius. This process reduces edge diffraction, and that in turn helps to tune harshness out of your panels. Now, if your new radiuses aren't perfect, don't stress because our next step is going to be sanding. Here, I started by smoothing out my cuts, but then I progressed into rounding over all the outside edges, which again helps to further reduce edge diffraction. Then, when it came time to do the fronts and backs, I didn't want to waste any time, so I pulled out the big guns and sanded them with my 6-inch random orbital sander. Now, this might seem like a pointless step, but according to audiophiles online, it's actually very important. You see, during the manufacturing process, they melt the outside skin of the foam in order to seal it. This creates a high-density layer, which then, in theory, reacts differently from the rest of the panels. And as you've probably already guessed, that can hurt sound quality. So the idea here is to just sand off the skin using some really high grit sandpaper. Now, I'm a bit skeptical that this step really matters because of what we're gonna do next, but it couldn't hurt and it only took a few minutes. After the dust settled, I grabbed some PVA glue and then thinned it out as much as I dared with some water. The idea here was to use this concoction as a homemade sealer. The sanding process left the panels with a bunch of open pores, and the glue should close them up while still remaining as lightweight as possible. Of course, this then raises the question of why do we even need to do that? And the answer has nothing to do with sound quality and everything to do with looks. Once these panels are mounted in my office, I want them to look as minimal as possible. So I decided to paint them the same color as my walls. Or at least what I thought was the same color as my walls. More on that later. Obviously though, this paint has some weight to it, so by pre-sealing the panels, I was able to use fewer and lighter coats to still achieve full coverage, which theoretically mitigates at least some of that high density skin effect. Now, if it sounds like I had to do a lot of research for this project, Well, that's because I did. But luckily, I had a secret weapon on my side that made all of it a lot easier. And that's Opera, the sponsor of today's video and my new favorite web browser. It is packed full of useful features that elevate it way above your typical browser. For instance, you can group tabs together into color-coded and labeled tab islands, which is extremely helpful when you're researching a bunch of different topics. I had one island for part shopping, one for acoustic design, one for material choices, etc., etc. And then tab traces allow you to visually track your most recently used tabs. The lighter the underscore, the more recently you viewed it, which was a huge help and allowed me to easily retrace my steps with 30+ tabs open. If you're a dark mode user like I am, you're gonna love all of the custom themes here too. There's animated backgrounds, custom sounds, and a ton of other customization. I've been using Obsidian, which is a very low-key vibe and great for deep focus. And then one feature which I found myself using way more than I thought I would is Opera AI, which recently got a huge upgrade. I asked it to analyze entire tab islands, and it distilled all of that info down into condensed high-level summaries, which honestly saved me hours of reading. Overall, Opera just feels like a truly modern web browser made for 2026. So to learn more or test out Opera for yourself, check out the link down in the video description. So that is it for our panels. Now let's get back to talking about the Exciter. And unfortunately, we're actually gonna have to fix a problem with this thing. Apparently, these exciters love to fall off panels after a very short honeymoon period. See, the double-sided tape that comes pre-applied to them must not be very high quality. So instead, we're gonna replace it with some much stronger 2-part epoxy. But first, we need to figure out where we're gonna mount them. And if you thought you could just slap these things right in the center of your panels, well then think again. Remember earlier how I said you want to avoid symmetry? Well, to help combat standing waves, you want to mount your exciters off-center on both the vertical and horizontal axes. Your mounting points should end up looking a little something like this. So now that we've got those marked out, next we can start gluing our exciters in place, and this is a great opportunity to talk about what makes these guys so special. First, as far as exciters go, they're pretty dang powerful. Each one can handle up to 50 watts. And to help spread all of that energy out over a wider surface area, they have this unique quad arm design. See, most exciters transmit their vibrations through a single point, which then limits the size of panel that they can effectively drive. These ones, on the other hand, can handle much larger panels, which helps them reach a wider frequency and should also help to avoid distortion at higher volumes. Now at this point, you're probably wondering why I made 5 panels when I only have 2 exciters to mount. So let's talk about that back in my office now that the epoxy has finally cured. All right, so now that we got our panels looking nice and good, we are ready to move on to our first major challenge. We need to find a way to mount these things. It's gonna be a little bit trickier than you might think. See, these panels need to float in space so that they can move back and forth and generate sound. Now, what most people do is suspend them from above, so they're just kind of hanging there, but honestly, I really don't like that look. So instead, I want to create an invisible suspension system on the backside of the panels. And the reason I made extra panels is because I knew this whole process was going to involve some trial and error. Over in Fusion 360, I whipped up my first draft of the mounting system and then fired that off to my 3D printers. Now, most people are happy to let their 3D printers automatically orient whatever it is they're printing. But here, that could end up being a costly mistake. See, much like wood, 3D prints have a grain to them where they're stronger in some directions and weaker in others. So I set up this print so that the load of the suspension system will be pulling along the strongest axis. This should help to prevent the clips from snapping or potentially deforming over time. And now that they're done printing, I can show you exactly how they're gonna work. These black clips will get affixed to our panels, and they have a hook that's perfectly sized for these rubber O-rings. These white clips then hook onto the opposite side of the O-ring, and they get affixed to the wall. There's a slot here so I can dial in different levels of tension, and that tension, bound up in 3 opposing O-rings, is what's going to allow our panels to float in space. But as you can imagine, placing these parts accurately is going to be crucial to making the whole system work, so that's why I also printed these guides that precisely locate the clips on each panel. Using the same 2-part epoxy as before, I carefully glued them in place and then gave the chemicals some time to work their magic. So while we wait for that, let me show you how we're going to keep the corresponding wall clips aligned. These ones were trickier as I didn't have the panel itself to use as a reference, so instead I made this giant jig that was actually so large I couldn't print it as a single piece. But after gluing it together, I was ready to test it out. Using my favorite home improvement tool, the laser level, I spent a few minutes mocking up where the panels will eventually go. The main consideration here was just placing them far enough out so that they wouldn't be obstructed by my screen. That's a big no-no in terms of sound quality. Now, as you can see, at first my jig worked great for locating all 3 mounting holes. But then when I went to install some drywall anchors, things started to go off the rails. The first 2 went in without a problem, but the third one hit something that felt suspiciously not like a stud. Oh no. So rather than risk puncturing a water or electrical line, I decided to just bite the bullet and move the whole setup a couple of inches to the right. Unfortunately, this does mean I'll have to do some drywall repair, but we'll worry about that later. For now, I mounted my 3 wall hooks, fitted them with some O-rings, and then got ready to test out my suspension system for the very first time. And at first, the results were kinda lackluster. The panel didn't feel very taut, and my clips were actually hitting each other. But after taking the panel down and making some minor adjustments, things started to look a little bit better. The panel floated nicely between its 3 anchor points and moved back and forth with very little resistance. However, I noticed that my design didn't allow for a lot of movement along this axis, so I went back to Fusion 360 and made some minor modifications. This new design should allow for a wider range of movement, and I also made the wall clips significantly beefier so they won't flex under tension. And while I waited for those to print, I busied myself by setting up the mounting holes on the opposite side of my desk and also patching all those holes I made a second ago. So at this point, I had my new clips printed and ready to go. And while part of me was tempted to jump straight to the real panels, I decided to play it safe and do one more test. However, that was probably a waste of time because the new suspension system worked really well. It has a much wider range of movement and felt significantly stronger. So finally, I was ready to move on to the real panels. And if all of this seems like a lot to figure out for a set of speakers, that's because it is. But I don't want that to discourage any of you guys at home from attempting to make your own panel speakers. So that's why I condensed all of my research and design into one easy to download package. It'll include a parts list, measurements, and 3D print files for all the jigs that you've seen me use so far, plus a bonus 3D print file that we'll get into later. To download it, just scan the QR code on screen right now or check out the link down in the video description. It should save you a ton of time. All right, so now that we have our panel speakers mounted, next I want to talk about how we're going to power them. As you might have already guessed, we can't just plug them directly into my PC because the signal that my PC outputs isn't nearly strong enough to drive them. So between our new speakers and my PC, we need an amplifier. And the amplifier that I chose for this particular project is this Fusi Audio BT30D Pro. This thing is compact, has easy to adjust front dials for EQ, and it even supports Bluetooth in case I want to connect my phone to it. But I'm getting ahead of myself. First, let's just focus on getting this guy hooked up. And here we have a great opportunity to dispel a really common myth. See, a lot of people think you need the wires that connect your left and right channels to be the same length. The old wives' tale is that if they're different lengths, your speakers will fall out of phase. But the reality is the electrical impulses that power your speakers travel through the wires at roughly 2/3 the speed of light. So a difference of 10 or even 20 feet is never going to be perceptible. In fact, if you did cut your wires to be the same length and then spooled up the excess, you might accidentally create a weak inductor coil, which could then introduce some real interference. But long story short, just cut your speaker wires to whatever length you need, as it'll make your cable runs a lot cleaner. So now that we're done myth busting and everything is all hooked up, I finally got a chance to sit down and listen to my new speakers for the very first time. And the results were not what I expected. I'll be honest, I don't think I have ever been this conflicted about a set of speakers. First off, the detail and the clarity is unreal. I can hear things with these that I could never hear on a normal set of speakers. But the mix is so bad. The mids are completely overpowering and the highs need quite a bit of boosting, which I think I can fix with some software EQ. But the lows, Oh man, I don't think there is any amount of EQ that can make these things sound good in the lower range. So that's why I immediately ran out and bought this 6-inch subwoofer. This guy should fill out the low end and compensate nicely for the panel's lack of bass. But you're probably looking at this big speaker and wondering how I'm going to integrate it into my setup while still remaining true to my theme of saving space. Well, here, I think I've come up with a fun solution. Using my 3D printer, I'm gonna create a stealthy enclosure that should make our sub practically invisible. The only problem was that due to its design, it was gonna take a long time to print. Oh, that is a long print time. 1 day, 21 hours and 28 minutes. That's definitely my longest print yet. See, the biggest challenge to making a 3D printed sub is that it needs to be strong enough to withstand the huge swings in internal pressure. So this box has very thick walls, rounded internal corners, a whole bunch of internal bracing, and it's printed in super strong glass fiber reinforced ABS. It even has an integrated port that tunes it down to 46 Hertz. And while I was clearly very excited about the challenge of 3D printing a subwoofer, I was a little annoyed that most creators I saw praising these speakers completely glossed over their lack of low-end reach. That's not exactly a small detail to leave out. Regardless, I decided to press forward and keep going. So let's talk about what I did while I waited for that enclosure to finish printing. Call me crazy, but the paint I used on my panels didn't quite match the paint on my walls, so my first job was just repainting the entire wall behind my desk. And while I had the paint out, I also gave the speaker wires a quick coat. This should make everything blend together really nicely, and it finished off my drywall repairs from earlier. But that wasn't the only mod I had planned for the speaker wires, because I also ordered a set of 150 Hertz bass blockers to solder into them. See, our panels are so bad at generating low frequency sounds that it's better to just completely cut them off from the lower end of the sonic spectrum rather than having them conflict with our dedicated subwoofer. It's kind of like how having one good bass player performing solo would be better than having a good player and a crappy player trying to harmonize. Beneath that heat shrink tubing is a simple capacitor that physically blocks frequencies below 150 Hertz from traveling to the speakers. It's a pretty neat analog solution to our problem. So, after connecting everything back to the amp and getting a good night's sleep, our subwoofer box had finally finished printing, and this thing was beefy. But it wasn't ready for service just yet. Decoupling a subwoofer from its mounting surface is a great way to isolate it and increase sound quality. So that's why I got this roll of thick, self-adhesive neoprene foam. Basically, it's gonna act as a gasket and keep the subwoofer's vibrations from transmitting into my desk, where the subwoofer will eventually be mounted. And this foam should also help to reduce resonance, which, you know what, let's go ahead and give this thing a quick resonance test. You can hear, that's not bad. That's not bad. That could be better. And then that surface is quite resonant. In order to dampen those vibrations, we're gonna use some sound deadening butyl rubber. You might know this stuff as Dynamat, Killmat, or a multitude of other brand names, but its job is to absorb vibrations. Sticking it to the flat surfaces inside the sub helps to ensure that you only hear the vibrations from the driver and not its enclosure. And honestly, a little bit of this stuff goes a long way. It's pretty crazy to hear the difference that it makes. After soldering some speaker wire onto the driver, before I could install it, I had to make my own gasket. Because this is a ported sub, if I want it to operate properly, I need to ensure the only way air can move in and out of it is through the port. So this foam ring seals the driver hole and makes the whole box airtight. Now, before we install this terminal cup that I'm wiring up here, I've got one last treatment for the subwoofer, and that's just a little bit of polyester filling. This stuff, again, helps to dampen internal vibrations, but also, through some physics that I don't really understand, it increases the effective internal volume of the enclosure, which basically gives you a bigger, deeper sound in a smaller form factor. And now, after all that, just listen to how neutral this thing sounds. My final step on the Subwoofer Odyssey was assuming the position and screwing it to the underside of my desk where it'll be practically invisible. See, the nice thing about low frequency sounds is that it's hard to tell where they're coming from, so rather than putting the sub on top of my desk where it would take up valuable real estate, we can screw it down here where it's out of the way and still have it sound just as good. After connecting it to the amp and making sure it didn't interfere with my keyboard tray, I was ready to play with an exciting new toy that had just arrived in the mail. Okay, so now that we have all of our speakers mounted, we have one last job left to do. Earlier, I tried to EQ these speakers by ear, and to say it didn't go well would be an understatement. So I went in search of a solution, and what I found is this calibrated measurement microphone. Basically, this thing allows you to take really accurate recordings, which on its own would be kinda useless. But when you connect it to a computer and download a special piece of software called REW or Room EQ Wizard, well then you can scientifically tune your speakers to deliver the best possible sound. Long story short, the way this program works is that it plays a sweeping tone from 20 Hz all the way up to 20,000 Hz. Our fancy $200 microphone then records it and gives you a visual representation of your speaker's frequency response curve. Basically, you want this line to be as flat as possible. Now at first, I started by making large macro changes using the physical controls on the amp itself. This allowed me to smooth out the transition between the sub and the panels and also balance out the highs, mids, and lows. Having an objective visual representation here of each test allowed me to tune the speakers with real confidence. And as you can see, things were starting to look a lot better. But there's a limit to what you can do with physical dials. Things get really crazy when you push this EQ button up at the top of the screen. Here, REW will take all of that data that you've recorded and use it to automatically create a custom EQ map that's tailored not just to your specific speakers, but also to the room you're recording in. So I took all of those values and set them up to automatically apply as soon as my computer starts. And now, I think we are finally ready to compare these new speakers to my old ones, which they will hopefully be replacing. So, after listening to both sets of speakers back to back and taking some time to reflect on this entire project, you're probably wondering how I feel about it. Well, yeah, about that. Honestly, at this point, I'm having a really hard time understanding why so many people enthusiastically recommend these speakers. This project was basically just a series of gotcha moments where I realized that I needed yet another piece of optional equipment to actually make these speakers sound good. In my opinion, I would never recommend these speakers without a dedicated subwoofer because they're gonna sound horrible. And unless you have great ears, you're gonna need some more equipment to properly EQ them. So just as a PSA, if you ever hear anyone recommending these speakers without those caveats, I'd take what they're saying with a grain of salt. Now, that being said, if you are willing to put in the effort, the final results are pretty damn impressive. I do much prefer these new speakers to my old ones, which already sounded really good. There's a level of clarity and crispness here that's hard to replicate with a traditional speaker. And the form factor is amazing. If you're a fan of a super clean setup the way that I am, these are an easy recommendation. Sitting at my desk, they basically just disappear and it's like the sound waves are coming out of the ether. They also free up a ton of desk space and make my office look a lot less cluttered, which I really appreciate. So overall, yes, I am a fan. I just wish people communicated a bit more honestly about all the things that it takes to make these things sound good. And on that note, I've actually got some thoughts about how I could have improved this entire project, and I've consolidated them all into a separate bonus video for channel members. So check that out if you're interested. And if you want to make your own panel speakers at home, again, the links to my instructions and all the 3D print files will be down in the video description.